going to show you how to solve Leetcode question 199 binary tree right side view, and it's a median Leetcode question. So given root of a binary tree, imagine yourself standing on the right side of it. Return the value of the node you can see ordered from top to bottom. So a tree look like this in example 1. What the result that they want you to return is the right side view. So basically the output you can see you want to get is 1, 3, 4 after running the function that you write. And then the second example is 1, 3, like 1, 3, the left side is no, and then the result they want you to return is 1, 3. And if it's empty, just return a empty tree. And there's some constraints here. And this is a interview question asked by Facebook 112 times in the last 6 months. Definitely a great question to practice on. So if you think about this question, return the right side view is not that tricky, but the problem is that if they want you to return something like a tree like 1, and then if the left side is 2 and 3, the right side of course is 1, 3, right? The difficult part is that if it's the most right side view on the level is not on the most right value. Let's say the child node of 2 has another child node of 4. In this case, the most right side view, although the 4 is on the left side, because the 4, there's nothing on the right side. So the most right side is the most right side view. So in this case, the answer they want you to retrieve is actually 1, 3, and 4. In this case, if you imagine a tree that all the connections are connected, and this is question can be solved by both breadth search and depth search, but relatively speaking, breadth search may be a little bit easier because breadth search is more of the level traversal instead of like depth search. But depth search, you can also do it easily by traverse to the end, and you can easily do it recursively. If you do, I'm going to show you how to do both ways. And if you do using the breadth search, what you can do is you basically append this value to the queue, right? And then when the queue exists, what I wanted to do is I want to pop the most right value. So like a queue, let's say I added the 1 to the queue, and then I want to pop the most right side value, which is 1. After I pop this value, I want to iterate through each length of queue. When I do that, when I pop the 1 value, after I pop it, if the child exists, when I pop the 1, I want to add all its child, right? When I add a child, if 2, I want to add it like this, 2, 3, which is basically the next level. And then what I wanted to do is I want to write the last value in the queue to the end result, right? So basically something like this. And I want to make sure that I write a 3 to the result. So previously I have already wrote 1, and I want to write 3 to this result. And then after that, I'm going to continue to pop the queue and add it to its child as well. Then when I'm going to pop the 2, right, I'm going to add 4, because 4 is the only child. There is nothing on the right side as well, and there's nothing else left. So then I'm gonna add 4. I'm gonna add a 4 because 4 is I want to add a last value from the queue to the result. So then it's 1, 3, 4, right? And then I'm pop the 3. 3 does not have any child, and then I'm gonna pop the 4, and the 4 doesn't have any child either. So in the end, the queue is empty. Then you have the result as 1, 3, 4. And then if you want to do the depth search is that you can easily do it recursively. And then if you want to involve the leveling, right? Because this is level 0. when the base condition is the length of the result equals to the leveling, then you can start appending the result. So let me write it for you. The length of the result, if length of the result equal to the leveling, and you can start append the result. The reason I'm saying this is because the length of the result at the beginning is 0, right? And the level started from 0 also. That's why we can simply just append the 1 to the end result first. And then when you do this recursively and you want to run the same DFS function on the left node and the right node, the tricky part is that you want to start from the right node is because you want to get the most right view. So for the child of 1 in the right side of the node, you want to, when you run DFS, you want to run this guy, that for search first, because it will ask you the right value. If you run this first, and when the length of the result, and there's a 1, because the length of the result, the second time when you run it, the length of result equals 1, right? And then this is level 0 here, and then when you go to 3, it's level 1. So that's why you're gonna append the result 3 here. So you want to make sure when you run the depth first search, you want to start the right node, and then you run the left node. That's the only tricky part you're gonna pay attention to, and then you just call this depth first search function, and then you will be able to get the result that you want. I'm going to show you first how to do this in code for the breadth first search. And we want to rule out some edge cases if not root, right? And I want to return no. And that's one of the example that they give to us for the breadth first search. I want to implement this queue by using by using a DQ here. So then I'm gonna first append the root value to the DQ before I start, and then I'm gonna assign a result, basically what we need to return here, to a list array here. So I'll say while Q, right? And I want to start append the value. The value I append in the example that I give to you is that I always append the right side of the value to the Q. Like the Q is like 1, right? I want to append, let's say that you already popped the 1 and then you have added a 3 in this case. If I want to append, so Q is always first in, first out. So if I want to, after I added 2, right? When I start popping from the Q, pop left, and it always pop 3 first. But in this case, I actually wanted to, when I add to the result, I want to add the right side value to the result here. So here is how you do it. The -1 is the last value from the Q, and then I want to append its value to the Q. That's basically what you need to do. Because if you don't append the last value, then it will not be able to get the 3 here. And then I'm going to go through the iteration for I in range length of the Q, right? And I'm going to go through each of the iteration, and I'm going to do the node is Q dot pop left. I'm still going to popping from the Q pop left. Every time when I pop a value, I want to add its child. When I add its child, I'm going to have to check if the child exists. So if no.left exists, right? If no.left exists, I'm just going to q.append no.left. And if no.right exists, I'm going to q.append no.right. But either way, every single time when you go back to the loop one more time, you will still be able to append the most right value, and then while Q, and then in the end I want to return the result, right? And that's the breadth first search. And you can see it works. And then I'm gonna show you how to do this in the depth first search, like recursively. And I'm already okay. So I want to keep the edge cases because it's essentially it's the same, and I'm gonna assign a result here. I'm gonna define a DFS search function, and I'm gonna pass two parameter. One is the node itself, and the other one is the level. And when I remember the base case I mentioned is that if the length of the result equals to the level, that's when I wanted to append the result to the end result, because at the beginning, right, level equals 0 at the beginning and the result equals to this is empty. That's why the first value I will actually append to the end result. The end result is actually the root value, which is 1 in this case. And then next time when I do it, I'll show you the recursive function. And then so I want to run this recursively, right? For the child in two items, right? One is the node.right and node.left. This is super important that you have to make sure you start from node.right, because what it's trying to do is get the node.right value. If you go through this recursively, you will see that why it needs to start with the node.right, because this node.right leveling is when you go through 3, right? And if you want to start the child node 3, at that time the result equals 1 and the level equals to 1. That's the time you're gonna append the second result. But if you start for child in node.left and node.right, if you start from the left and the result is 1 and the leveling is 1 also, if you append that result, you're gonna happen to end up appending the node.left, which is the wrong answer. So that's why you gotta have to make sure the node.right is on the is the beginning of the list. So if the child node exists, if the one has a child node, right, I'm gonna run the DFS search on the child node itself, basically repeating the same thing, but the leveling, since I'm down 1 level, I want to say level +1 in this case. And then that's it for the DFS search function. And you just wanted to call the DFS search on the root node, and the leveling start from 0. And in the end, you return the result, and that should be what you are looking for essentially. Okay, if you think that this is helpful, please like my video and subscribe to my channel, and I'll see you with more Leetcode questions soon. Bye bye.